All right. So after learning about the open spheres, we can talk of open set, which is also a very important concept to develop the theory of analysis, or I can say topology. So what is open set? So when I can say, if you are sitting on a room, let's talk what should be the idea to define an open set. Suppose when you can say that you are sitting on an open room, what should be your idea to define open set? Or in general, physically you can say that when you can say that you are sitting on an open room.
when it has no boundaries.
I am not. Your voice is not was not clear.
Sir, when it has no boundaries.
Okay, so one of the idea is that we can say that we are sitting on an open room. That means there will be no boundary. That means there will be no wall is there. But how you can define there is no wall in that room? So that means something is come from the room itself, because you have to define a boundary. To define a boundary, it has to be come with the room itself, because room is open. When you say room is open, that you have to define a room first. That means this is area is my room, and from that area you can able to define open set or open room. Do you understand what I am saying?
Yes, sir.
Yeah. So this is the, suppose I want to say that this set is open, then it has to be come from the set itself. There has to be something, some portion of the set itself is to come, and from that set you can able to define an open set. So the definition says that if you pick up any point in this set, so I can pick up any point on the room, and if I can draw an open point. So what I'm saying, you can pick up any point in the room, and if you can able to draw an open neighborhood of or open sphere of that point, such that that sphere is totally lies inside the room, then we can say that that room is open. So first of all, you have to define what is your room. This is my room, and in that room, I pick up any point, draw a neighborhood of that, any neighborhood, not any neighborhood, but at least one neighborhood should be there. Okay? If that neighborhood is lies inside that room, then we can say that that room is open. So mathematically, if I can say, to define this neighborhood, you require a metric space. So let X be a metric space. And G be a subset of X. For every X in G, there exists R greater than 0, such that S R of X is subset of G then G it's called an open set. Okay, so please be careful about the definition. Students are making a mistake here. Here it is for every x. So the things is happen to every point inside the room. There exists one, at least one. There are many, I don't mind, but at least one are. That means there are at least one neighborhood such that that neighborhood is lies inside that set, completely inside that set. Then that set G, it's called an open set. Understood? This is your set G. This is the open sphere SR of A, which is inside that set. So this is the definition of open set. In short, the open set means that each point of G is a center of some open sphere contained in G. So what I can write as a note, very important thing, that an open set means if each point of G is the center of some open sphere contained in G. And a set is open if each point, in another way to looking at the point open set is a set is open if each point is inside that set. The inside, I'm just saying inside means it having this property. In the exactly the same way I can say the room is open, that means every point is lies inside that room. Inside means here this is the thing, that means every point has an open sphere contained in that set. So it is a precisely sense inside is in this manner. Now we can talk about some examples here. When we can say the set is open, or you can have some examples, then you can visualize, yeah, this is the set, we can say it is an open set. This is the set, we cannot say it is an open set. For example, I can talk about the simplest example as a singleton point. Let's say one point x0, where x0 is belongs to R. So this is your real line. On real line, there is a set contains only one point x0. Can we say that this set x0 point or x0 set is an open set? First of all, what is your idea about this? The definition says that it has only one point. So this point contains one open sphere which has to be lies totally inside that set. What is the definition of open sphere? In R, that we have seen, what are the open sphere in R? They are the open interval x0 minus R to x0 plus R. That is the neighborhood of the point x0. So this is the neighborhood of this. For some, there at least one R positive is required, which is inside this x0 set. Is it possible? Can you able to find out some R which is positive such that this open sphere or this open set is inside this set, because this set is contains only one point, so it is never be possible. So I can say there will be no open sphere of x0 which is inside this point or this set. So that means this singleton set x0 is not open set. In fact, why it is only one point? If I take 3 points or 2 points or a finitely many points, then that set is also not an open set, because the same argument can be given. Let's say I have a point x1, x2 up to xn, and this x1, x2 up to xn, all of them are belongs to R and is a finite set. So the same argument can be given for x1 as I have given for x0 here. The same argument can be given for x1, x2 if I can assume x2 is here, x3 and so on, because there is no neighborhood. It may possible some of the point are lies in this neighborhood, but not all. Okay, so that's why I can say that any finite set over the real line, that also not be an open set. Let's talk about the third example. Let's say x is equal to R, and the set G I am taking as open interval or close 0, open 1. Can we say that this is an open open set? What is your idea, or what you can say? Tell me.
Yes, sir, it will be an open set.
It will be open set. One person is saying that it is open set. What about other?
So this is not an open set.
This is not an open set. Can you tell me the reason why it is not an open set?
Sir, for the point 0, you cannot find any open neighborhood which is entirely contained in your set.
Set G. Why? Because see, the neighborhood of 0 is look like 0 minus R to 0 plus R. This is the neighborhood of 0, or I can say open sphere of 0. 0 is here. So this is the neighborhood of minus R to plus R. And this portion will never be inside G. Never. So I can say that 0 in that sense not inside G. Okay, in that sense means in that way, the sense where we are talking. So for 0, the condition of the open sphere or open set is not satisfying. So therefore G is not an open set. Yeah, for other points it is there. For example, any point if I take x0 here, then x0 you can able to plot some neighborhood of this x0 minus R and x0 plus R. So for this point, that even though for point 1 also we have the same thing, because 1 is not inside the set. This is not a closed interval, this is open interval. So you cannot take 1 which is in belongs to G. Okay, so it is an open interval here. So for that all the points we have, but only the problem is at 0. So I can say that this G is not an open set. But yes, if I define G as open interval 0, 1, then it is an open set. Same way, you can say closed interval 0, 1. This is also not open set. This is not open set. This is an open set. Okay. Let's talk the next example. Let us consider x is equal to r square. See, whenever I'm talking this x is equal to r square, I'm just talking about the usual metric. So in the previously also we have talked this example with the usual metric. I should mention that. U means, what do you mean by usual metric? That a distance between x and y is mod of x minus y. Here the usual metric means this square root of x1 minus y1 square plus x2 minus y2 square. That is the usual metric. This is the metric you have. So in that matrix, I'm talking about this set. Let's say this set defined as A such that set of all xy where x is between A and B. Let's say this less than or equal to A. A is less than or equal to x less than B. So geometrically, you can see that what is this represent? If this is your x-axis and y-axis, then geometrically you can say that if this is your line, x is equal to A, and this is your line x is equal to B. If I consider A and B are positive, so this is the line x is equal to A, and this is the line x is equal to B. But according to this, the whole portion is not there. That means it is a dotted line there. So this is the dotted line. Not this line is not included in this set. Only x is equal to A line is included in this set. What is your, what you will say, whether this set, first of all you just see the what is the open neighborhood of this r square with this metric. The open neighborhood is an open disk that we have discussed. Okay, and with that open disk, can you say that this set is open? What is your idea, or what you want to say about it?
Not the open set.
This is not an open set. Why?
For point A, we cannot draw open sphere.
Point A means this is in two-dimensional quantity. So what does it mean of point A?
We cannot draw a circle.
Not point A, but it is two-dimensional, na? So if I can say this point, it has two coordinates. Has two coordinates, na? This point.
Yes.
Any point on. So point means which point you are talking?
All points.
All the points on x is equal to A. That is the proper way to say that. Any point on the line x is equal to A which does not have an open sphere, which is lies inside the set. Because any point on this set, if I take, and if I'm trying to draw trying to draw an open disk of this, then this portion is always outside the set. So that's why any point on this line x is equal to A will not be satisfying the condition of open set. So that's why this set is not an open set. So A is not open set. But if I define a set B, which is as set of all xy, such that A is less than x less than B, if I not include its boundary, means this x is equal to a line and x is equal to b line, then this D is an open set. Because for any point inside this strip, we'll always have one disk which lies inside that set. So in that case, or in that sense, we can say that this is an open set. Now, what is your somebody says about the boundary condition? Will it be satisfied here? Means if you can see in R2 or in R3, any object, if you can want to say that, you just need to say whether which having this property or not, or which having the boundary or not. Now I have not defined, there is a term boundary into this metric spaces, but still I have not defined a boundary here. Okay, but in our intuitive way we can say that, yeah, if this set is open, it does not have a boundary. But what do you mean by boundary? I have not defined yet. Boundary of a set, that we will also define later on, but intuitively you can say that. Fine. So with this couple of examples, I can gives you one of the exercise also to try. If I define or if I change this metric with other metric, that means drawing this type of neighborhood or drawing a square neighborhood, whether this set A is an open set in that, or can you able to find out other open sphere which are, or other set which are open in this but not open in another one, and vice versa. These are some of the, I can say, questions that which is not included in this theory, but you can try to find out what will be the relation with open sphere. Can you have some open sphere or open set which is open in this metric space but not in a different metric space? When space is same, this x is same, but just you are changing the metric. Okay. So let's have the another one of the example. So I can define a set which having a discrete metric. So what are the open set in a discrete metric? So I can have X is a non-empty set. So X I am taking as a non-empty set, and discrete metric I am defining on it. That is set of all x, y such that it is 1 if x is equal to not equal to y, and 0 if x is equal to y. Can I say the singleton set x0 is an open set in this x comma d? That means in this matrix space, can I say that x0 is an open or not? What is your idea, or what you can say about it? So first of all, you should see what is the neighborhood of this x0. Can somebody see what is the neighborhood of x0? As per the definition, SR of x0 is that of all x belongs to x, such that D of x comma x0 is less than R. There are two possibilities of this: either x is equal to x0 or x is not equal to x0. So there will be two possibilities of this D. Either it is 1 or it is 0. So if I take R will be 1. If I take R is 1, then what is S1 of x0? X belongs to R or X. What will be this? If it is 1, only D of x comma x0 is less than 1. What is the value of x is equal to x0, or what will be the things you got here? What is the set contains? Anybody?
Only x0.
Only x0. Only x0 is the set contains. Because R is 1, so there will be two possibilities there. Either x is equal to x0 or x is not equal to x0, but x is not equal to x because this quantity is strictly less than 1. So this open sphere contains exactly one point, x0. No other point is there. So now we come to our original question. Can you say that this set is an open set?
Yes.
Yes. Yes. Why? Because we need to now check for this point x0. What is the neighborhood? There has to be at least one neighborhood of this x0 which is entirely inside this set. That we have. This is the neighborhood S1 of x0, which exactly x0, which is inside this set x0. So that's why this x0 point singleton set is an open set in this metric, in this discrete metric. In fact, same argument can be given into this set of all any subset of x you can take. So ultimately what we are saying that every point has an open sphere which is a singleton set. Every point has an open sphere which is a singleton set. Will you agree with that statement due to this argument? Now let's say x0 is any point in this set A. Same argument given, this x0 is already lies in A. So that's why this set x0 is also lies in A. So same argument can be given for any point in this set. So that means what is my concluding remarks here about this discussion is, can somebody conclude that? What I'm trying to say.
Sir, every subset of X will be open in discrete metric.
Yes. So any subset of X with discrete metric is always an open set. So in this discrete metric space, any set you can pick, it will be open set. In the previously, what we have discussed is singleton x0 is not an open set, but it is as a subset of R or a metric with usual metric, R with the usual metric. That we have proved. Here we are saying that the singleton 0 is an open set. Why this is happening? Due to the different metric is defined on a set. So if I take R with usual metric, then this is not an open set. But R with discrete matrix, then this set, singleton set, is an open set. So it may possible that one set is open in some metric, but in another metric, to change the metric, the openness will destroy. So whenever you are talking about this open set or open thing, then always it is better to mention in which metric you are talking about. That is most important thing. If it is not given a metric, then there is no meaning of whether this set is open or not. As I have discussed here, the same thing. So now we have a couple of theorems to be discussed on open sets that we will discuss later on. For today, we will stop here. So you have any question?
Sir,
Yeah.
sir, in this last discrete metric, um, can we say that any function will be continuous?
Yes, but I have not yet defined a continuity on
Okay,
a
okay.
metric space. Yeah, you can
I
say
was
that.
just wondering.
Yeah, you can say that. Definitely, you can say that if a function is defined over the discrete metric space, then f is continuous. Always. Any function you can define. But if it is defined on a discrete metric space, then it is continuous. But still, the continue, what do you mean by continuous function? In a metric space, we have not discussed yet. We will discuss later on in the second unit. But yeah, you are saying it is right.
Okay, sir.